Okay, today we have a topic on automated farming system and robotic. Okay, today we have the session with Mr. Prajwal, assistant professor at GPS Institute of Agriculture Management, Bangalore. He has the welcome you, sir. Today he has three international patents, 10 Indian patent, four books in AML, digital sensors, remote sensing, and JS, and one Asian Book of Record and one Guinness Book of Record. We welcome you, sir, for this session.
Thank you so much, sir.
Yes.
Good evening to one and all. So I can take the session from now. So today we will be, and firstly, I would like to thank for giving me an opportunity to discuss about the automated farming system and robotics from our Guru Ram Rai University and Meadow Agriculture. So kindly, any of the participants, I'll be sharing the screen. Kindly please confirm me whether it is on a slideshow mode or not, sir. I hope so.
Now
It is on.
slide mode.
Huh?
Slide mode. Slide mode.
Okay, sir.
Okay, sir.
Thank you, one and all. So today I'll be discussing about the basic introduction, firstly, of the automated farming system. So as we all know that it is a revolution which has created mainly in our agriculture sector for improving the efficiency, accuracy, and output. Parallelly, it is also going to reduce the labor cost and minimize the effects on our environment. So the automated farming system mainly focuses on the various agriculture operations, often incorporating of our sensors, data analytics, AI, to monitor and manage the crop and livestock. The key components in our automated farming includes our drones, field sensors, automated irrigation system, and data analysis. When we are going to speak about the drones, as we all know, drones are basically used for a surveillance purpose and precision farming. Parallelly, field sensors are used to monitor the soil condition and weather patterns and crop health. Automated irrigation system is going to optimize our water usage based on the real-time information. All these things I'll be just covering in detail in the upcoming slides. Data analysis tools has already been discussed, which is going to deliver the actionable insight for enhanced crop management. Same way, robotics in agriculture. Robotics is nothing but which is going to reduce the task for the human and improve the productivity and decreasing the relying on our human labor. You might ask me, which are the notable examples, sir, for robots? If that is a scenario, I can give you some of the few examples which are already available in the market, sir, like our robotic harvesters, weeding robots, autonomous robots, and there is a new one which is called as a robotic bees. So robotic harvesters, as we all know, it is mainly used for collection of our fruits, vegetables, and flowers. Robotic harvesters, whichever I told you. Same way, our weeding robots mainly works to detect and eliminate the weeds without damaging our crops. Autonomous tractors is nothing but the which has been capable of plowing, planting, and applying fertilizers and pesticides without any kind of human intervention. The most interested one is our robotic bees, which are mainly developed for pollination. In some parts of the world it has been used, mainly like our Israel, USA, and UK. You might also ask me, sir, which company has developed the same. So Aruga AI is one of the company which is put up at Israel, has developed the robotic bees for pollination purpose. Same way, even our Walmart, which is a well-known company in USA, has also patented on the same. Even many research institutions in US, UK, and many other nations are working on this robotic bees on the field. So, why is it necessary for implementing automation in the agriculture sector? Mainly to overcome the labor shortage. Next, it would be our increasing the food production, efficiency in the resource management, adapting to the climatic changes, reducing cost and enhancing the profitability. Mainly every farmer is going to ask us how to reduce the cost and how to enhance the profitability. improving the quality, promoting the sustainable and eco-friendly farming are some of the key necessity for implementing the automation in our agriculture sector. Automated farming and its components mainly covers as whatever the automated farming, we also refer it as our smart farming or agriculture automation, all are one and the same, which is going to involve the application of various technologies like our robotics, AI, IoT, machine learning, which is again a part of our AI, to carry out different agricultural activities with reduced amount of human involvement, where it is going to encompass various processes like our planting, irrigation, fertilization, harvesting, and monitoring of crops and livestock through automated systems. You might ask me, what are the common components which are being used in the automated farming system? Some of the examples are like our smart machineries and robotics, IoT and smart sensors, artificial intelligence and data analytics, automated irrigation system, GPS and remote sensing, automated fertilizer and pesticide system. Usually, I generally call it as a fertilization in my upcoming slides for the fertilizer terminology. Parallelly, smart greenhouses, automated supply chain and logistics are some of the areas where our automated farming system components have been used in our day-to-day life. So what is the history of automation in agriculture? The evolution of automation in agriculture actually began in the year of 1920s with a significant progress in the sector of advancement in robotics and AI, leading to the machines that are increasingly cost effective and dependable. The major milestone was established in the year of 1920, where the initial research on the automatic guidance system for agriculture vehicle was began, and they were able to reach a milestone in the year of 1950 to 1960, where the development of autonomous agriculture vehicle commenced. Through this, they still relied on a cable system for navigation. So currently, whatever we are using is a wireless navigation system. Whatever the GPS systems which are available in our mobiles or GPS modules which we are going to use in our vehicles, it is a wireless system. There is no any kind of wire. But in that generation, it was completely a wired system. So that is what they were able to reach the milestone in that specified year. Parallelly, in 1980s, the advancement of the computer enabled our machine vision guidance technology. The current development during the 1990s and the current year, in 1990s, the integration of GPS technology was successfully done in tractors for precisely mapping our farmlands. The present days, as we all know, the drones are commonly employed for crop management, enhanced efficiency, and also minimizing our labor demands and pesticide exposures. So what are the types of automated farming systems which are available? Precision agriculture, which we also call it as a precision farming or smart farming, which mainly represents with the cutting edge technologies like our data analytics, automation, which is going to enhance our farming techniques. The methodology behind this is to enable the farmer to make informed decision regarding when to sow the crop, when to sow the seed, how to manage the irrigation, when to give the fertilizers, harvesting process, and how they can result with the improved efficiency and how they can also lower their expenses with respect to the sustainable agriculture practices. Same way, vertical farming. So vertical farming, whatever we are going to speak here, the photo itself speak, it is under the controlled conditions. It is going to represent a ground break technique for cultivating the plants in vertical arranged tiers, commonly within the control setting, as I told you, within a common structures or in some shipping containers or in our warehouses. These are some of the examples. The strategy of optimizing this space utilization is going to enhance the resource efficiency and facilitate the continuous production throughout the year, irrespective of any kind of climatic or any other factors, which is not going to affect in the controlled conditions. So, what are the key technologies in precision agriculture, benefits and applications. So, as we all know, from last 3 days, we are speaking about like GPS and GIS system. GPS basically facilitates us to accurately check with the field mapping, navigation, and the guidance of the automated machineries, whereas our GIS evaluates our soil condition and monitor crop health. As I was looking out with the session with the yesterday, one of our participant was also questioning, can we use GIS with IoT? So I'm going to explain what is actually IoT is going to do with our GIS, etc. IoT is nothing but a network of connections. GIS is a software where we are going to implement our data over there. So that is the major difference. So what are the advantages of our GPS and GIS? Mainly, it is going to minimize the input waste and enhances our field management. IoT and smart sensors. This technology gathers the real-time data regarding our soil, moisture, climatic condition, and crop health. The major advantages of our IoT and smart sensors are, which is going to allow us to monitor us on real time, and which is also going to optimize the resource utilization. VRT, variable rate technology, which is a very important thing for fertilizer, pesticide, and water-based on real-time data from the field. And the advantages of VRT is it is going to reduce the expenses on the cost of our fertilizers, pesticides, and also it is going to lower the input cost. AI and robotics, which is another thing and a very important thing. AI basically processes our agriculture data for predictive insights, while the robots are going to automate our task. Kindly get a difference between AI and robots. AI is basically going to process our agriculture data for certain predictive insight, whereas our robots are going to make our task automated, like harvesting or weeding, etc. So you might ask me, what would be the advantage of our AI and robotics? It is basically going to lower the labor cost and boost the efficiency. I am again repeating, the advantage is it is going to lower our labor cost and it is going to boost the efficiency. I'm not saying the entire system is going to be at a lower cost. I'm just speaking about the cost efficiency of the labor and the efficiency of the work. Blockchain and supply chains will be smart, where the technology is going to guarantee our food traceability and secure direct transaction. The major advantage in blockchain and smart supply chain, it is going to improvise the food safety and transparency within the supply chains, are some of the key technologies of our precision agriculture. What are the benefits of precision agriculture mainly? So mainly we have how to increase the crop yield, lower cost with our water, fertilizer, pesticide and labors, promote sustainability and environmental conservation, enhances the decision making through real-time data. Automation is also going to decrease the manual labor requirement, and it is also going to give you a better food quality and safety. These are certain benefits of our precision farming. Okay, sir, everything is fine. What is the application of precision agriculture? Might be a question from your end. Some of the applications of precision agriculture are as follows, like our smart irrigation system, precision seeding and fertilization. You might ask me, how is it precision seeding and fertilization? Mainly, it is going to work on a GPS guided seeding and VRT fertilizer, which is going to promote the uniform crop development. Pest and disease management, where our AI and drones are going to identify the pest outbreak on an earlier condition, enabling the target interventions, what we can try to target. Livestock monitoring, where wearable sensors are going to monitor the animal health and help us to prevent the diseases. Automated harvest, AI-enabled robots, which is going to efficiently harvest our fruits and vegetables, are some of the key applications in our precision agriculture. What are the key technologies we are going to use in our vertical farming? So some of the key technologies in vertical farmings, as many of them are much more expertized in this compared to me, like our hydroponics, aeroponics, aquaponics, even our LED grow lights, climate control system, automated monitoring, and AI. So hydroponics mainly uses soilless farming technique where plant roots are grown in a nutrient-rich medium, where the major benefits of doing it in hydroponics is it is going to use almost a 70 to 80% of less water than our traditional farming. Even the study says that close to 90% of less water than our traditional farming. Aeroponics, where plant grows mainly with a air or mist environment with nutrient space sprays. The major benefit here is to require around 95% of less water, and it is also going to promote for a faster growth rate. Aquaponics, a closed loop system where fish waste provides the nutrients to the plant. Benefit of aquaponics is mainly using our zero chemical fertilizers needed and sustainable fish farming. LED grow lights. Usually we have seen in our some of the areas where we use it for our marigold crop, where this LED grow lights works as artificial full spectrum lighting, which is going to replace the sunlight. The benefit in the open condition is to avoid some of the pest attacks in the field, was the feedback what we got from the farmers. In the same way, when it is in the closed condition, it is going to enable year-round indoor farming, where we all know how our photosynthesis process, what is the very important thing for the photosynthesis process. Climate control systems. Mainly AI and IoT regulates our temperature, humidity, CO2 level, and light exposure in our climate control system. The major benefit of this is optimal growth condition for plants can be taken care. Automated monitoring and AI, mainly sensor is going to keep a track with our moisture content, nutrient intake, plant health on a real-time basis. You might ask me, what is the benefit of using our automated monitoring and AI? It is going to reduce the labor cost and you're going to get the real-time data for the same. So the benefits of vertical farming is here the scenario is going to work with a year-round farming where there is no seasonal dependencies, space efficient where crops are grown in both urban areas and small spaces, water conservation is taken care, pesticide free where under the controlled environment which is going to eliminate, I'm not going to say the complete amount of pest, higher crop yield which is going to grow you almost the double or 3 times the crop yield under the closed condition, sustainable and eco-friendly, which is going to reduce the carbon footprints in transportation cost. What are the applications of vertical farming? So the major applications of our vertical farming is our urban agriculture, which is going to include our farm produce in cities and high-rise buildings, and farm-to-table restaurants, which is going to supply locally grown fresh ingredients directly to the restaurants. Space farming, which was developed by our NASA for the food production in space machines. Medicinal plant cultivations under the controlled conditions where we are going to grow various herbs and medicinal plants. Sustainable food production addresses the food security and reduces our agricultural land use. Next, I would like to get into the roles of robotics and its importance in agriculture. As agriculture robots are commonly referred as agri-bots, which are the advanced automated system engineered to execute a variety of farming operations with a higher accuracy rate, more efficient, and it is also going to reduce the relay or dependency on our human labors. This machines leverages in collaborative work with our AI, IoT, GPS, and sensor technology to improve both productivity and sustainability in agriculture. The roles of robots are like autonomous tractors and smart machineries, robotic harvester, weed and pest control robots, smart irrigation and water management, livestock monitoring and automation. Parallelly, our crop monitoring and disease detections can be done using various techniques. So when we are going to speak about the autonomous tractor and smart machineries, it is a self-paced tractor which are capable of plowing, seeding, and spraying the crops with high precision rate, leading to the decreased fuel consumption and lower the labor expenses. See, I just want to add a term here. Major farmers are going to ask even with the terms of the current fuel rates are expensive. Probably everyone knows, I guess, there was a new invention in Zimbabwe by a inventor called Maxwell Sangolani Chikambutso, who claims he has invented a free energy vehicle using radio frequency wave for the energy. It is nothing but he has still not yet patented the same, but is our physicists who are there in the field, they are going to say very clearly, even we all know that how the thermodynamics principle is going to work. Energy can neither be created nor destroyed, but can be transformed from one state to other state. So majority of the physics scientists are not ready to accept these things because he is going to claim that he is not going to use any kind of fuel or electricity, but the vehicle is going to run without any of this intervention. He is claiming that I am going to convert the radio frequency wave to as a fuel for my vehicle. He has also launched the car in Zimbabwe on Feb 10th in front of our Zimbabwe president. Once the vehicle is in market, probably the same thing can be used in our, if it is in a success rate or if it is actually succeeded in the upcoming days. The same technology can also be incorporated in our smart agricultural equipments too, which is also going to lower the cost expenses for our farmers' fuel. Meanwhile, when I am going to speak about the robotic harvesters, it is equipped with our AI, where these robots effectively harvest our fruits, vegetables, flowers, and grains, ensuring a quicker and damage-free collection of the process. Weed and pest control robots is an automated weeding system, which is going to eliminate the weeds without the use of any kind of herbicides, while drone sprayers effectively targeted the area or ROIs, where we can easily target the area of the pest which has been affected and minimizing the use of chemicals. Smart irrigation and water management, where AI-driven irrigation solution optimizes the water usage significantly and reduces the waste. Livestock monitoring and automation. This system utilizes the RFID technology, where our robotic milkers equipments are available. The system and our animal monitoring system for health and milk process in dairy sector is also happening. Crop monitoring and disease detection using the drones and sensors equipped by on the robots. It can easily access the plant health, soil condition, and identify the diseases at an early stages. So you might ask me, yes, what are the importance of agriculture robots in our modern farmings? Mainly, it is going to enhance the efficiency, where the automation is going to save our time and cost savings. It is going to decrease the rely on the human labors, which is going to help to mitigate the workforce shortage in our agriculture field, boosts the productivity, where the robots operates continuously, increasing the crop yield. Finally, all farmers look out for the good amount of yield and good amount of returns. Precision agriculture, where our AI technology facilitates the targeted application like our water, fertilizers, and pesticide, as I already discussed, which is going to promote the sustainability. When I say sustainability, reduces the chemical usage, aiding in the conservation of our natural resources, strengthens the food security, which is going to ensure reliable food production amidst with respect to the climate changing conditions. Minimizes crop loss, which is nothing but early detection of diseases and making and avoiding our extensive damage of the crops. So next, we are going to go with the types of agricultural robots. So I'm going to handle with the 3 types of agricultural robots, namely our harvesting robots, weeding robots, seeding and planting robots. Harvesting robots is nothing but the equipment which is installed with the sensors cameras. When I speak about a camera, it is an AI-enabled camera. And robotic comes to recognize, collect, and categorize the mature crop. Where the leverages of our AI and computer vision technology is going to may help the robot to execute the function. How does the working principle of this robots are going to take place? So I'm not going to go with the detailed working principle on the technical aspect. I'm just going to tell you how the actual working of the robot is going to happen basically. So in the general condition, it is going to identify the mature crop. How it is going to identify the mature crop? If you are going to ask me, it is going to utilize our cameras and sensors where the robot can determine the optimal time for harvesting the crops, organize the harvest, robot strategies, the sequence in which they will gather the crop, collect the crop information. Based on that, it is going to employ a robotic arm or specialized tools to harvest the crop. This may utilize the gripper or suction cup for this purpose. Why we require gripper or suction cups? As I told you, we are also going to use certain robots, harvesting robots, flower picking, certain robots without, for flower picking, we should be very careful. On that condition, we are going to use the suction cups, which is made up of where the suction will be filled with air, which is going to just connect to the flower and it is going to cut the flower. So in this way, it is going to work. And robots can classify the harvested crops into various containers based on the ripeness, if it is a fruit or what type. Essential technologies like our RGB cameras, where this device usually capture the photo, accurately identify the location and produce. The next part, where our deep learning or the algorithm is going to play. The algorithm is going to enable the detection of fruit position within the image and make the gripper to choose whether it is a specific type of a produce which should be harvested, whether I need to go with the soft grippers or suction cups for the grippers for more delicate items. So based on this, we can try to categorize what kind of sections can be used, like whether I can go with the soft grippers or a pressure grippers or with the normal grippers to harvest the crop. The benefits of harvesting robots have the potentiality to enhance the crop production while lowering the labor expenses. Additionally, they are capable of functioning the continuous throughout the day and night. It can continuously keep on harvesting throughout the day and night. You might ask me, which are the examples or which are the companies which we have in the field of harvesting robots? Some of the companies which I would like to tell you is EFF Robots, Harvest Crow, Agrobot, Sweeper are some of the examples of our harvesting robots. Next is our weeding robots. Weeding robots mainly deploys with the usage of our machine learning, sensors, artificial intelligence, and it is going to detect the weed and eliminate them while ensuring that crop is remain unharmed. It is not going to damage anything to the crop. Without the damage to the crop, the action will be taken. So how the working principle of our harvesting robots are going to happen in this sense? It is going to identify the mature crop using our cameras and sensors. The robots can determine the optimal time for harvesting the crop, as we were saying. In the same way, here in the weeding robots, we are going to check. Firstly, we need to identify the weed identification, which is very important. In the weed identification, the robots employs the camera and sensor to capture the images in the agriculture field. Then those images will be processed at the image analysis level. It is using our computer vision technology where robots will be programmed to distinguish between the weeds and crop by accessing their color, shape, size. All this information data should be programmed to our robots. Without programming, the machine doesn't know to perform. So we need to have a n number of data. With that data, it can easily identify which is a weed and which is a crop. Probably here you might get a doubt. Sir, you are speaking about removal of weeds. Some of the beneficial weeds will also be removed or what? See, if we are going to train the robot, or if we have given enough amount of instruction to the weeding robot, so these are the beneficial weeds. If we have a certain set of the beneficial weeds, which photos, which has been stored in the database of our robots, it can try to recollect those data, and it can eliminate the beneficial weeds and proceed with the removal of the weeds. If we have not programmed with the beneficial weeds, even that might get damaged under these conditions. Next, action determination, which is very important, where our AI is going to enable the robot to determine the appropriate method for managing the weeds, whether it is going to involve in plucking or cutting, or we do have a weed removal technique using the robots by mechanical implements. Even we have the same robots where we can go with the herbicide spraying, and the latest technology is also going to speak about the lasers. Lasers, which is going to effectively eliminate the weeds. The benefits of weeding robots are, it is going to minimize the manual efforts. Weeding robots can operate independently, which can eliminate the needs of human involvement, enhance the productivity. These robots are capable of making instantaneous decision. If you want to make the robot to get an instantaneous decision, the information whatever our expert has given to the system should be to the top notch. If and only if the information given to the system is clear, then the decision support system will also help to take the decision on a better way. And next, it is also going to decrease the relay on the labor's accuracy, utilizing machine learning, and the robots can be more precisely detect the weeds and perform their best at the time. You might ask me which are the companies which are in the market who are working on this weeding robot. AgroIntelli, Pixel Farming, and EcoBot robots are some of the examples of weeding robots. Next is our seeding and planting robots. A seeding and planting robot generally functions by integration of our sensors, motors, and mechanical system, which accurately transfers a field by creating the small hole in the soil with a specified intervals, placing a single seed into each hole, and subsequently covers it with the soil. All these three processes will be completed. The process is executed along with a programmed route, while the robot adjusts to the field condition using the data from its sensors, thereby automating the planting procedure with remarkable precision and efficiency. Whatever the condition which it is going to say, this thing should be programmed by an expert who is present in the field. The working principle of our seeding and planting robot mainly works with the input and navigation, where the robot receives the instruction regarding the planting pattern, seed type, row spacing from the operator. Sensor guided, the robot along is going to plan the path, adjust to the field irregularity, and then perform the task. Where our seed dispensing system is going to start, where the seed metering devices is going to precisely count and release a single seed into the planting zone, and the mechanism often utilizes a rotating disc with a small compartment to distribute the seeds evenly. Next is our soil manipulation technique, where the plow or drill bit digs the small hole in the soil at the designated location. The seed is deposited in the hole. A covering mechanism of the soil then pushes the layer of the soil and secure the seed inside the land. The benefits of our seeding and planting robot mainly enhances the efficiency of resource utilization, such as our seeds, waters, fertilizers, and also minimizing the ecology impact of agricultural methods. Additionally, these smaller machines can elevate the issues related to soil compaction in contrast to our conventional planting tractors. Some of the examples of seed and planting robots are our FarmDroid FT20, R2V2 is a one of the very good example, and smart seed sowing robots is another set of examples of our seed and planting robots. Autonomous tractors. An autonomous tractor is nothing but a self-operated agriculture equipment which has a cutting edge technologies which has been included with our GPS, sensor, AI, and computer vision to carry out certain farm activities independently and eliminating the necessity of a human involvement. What are the applications of autonomous robots? If you're going to ask me, it is going to help in plowing and soil preparation, where our automatic tilling, plowing, and leveling for optimal soil conditions. It is going to reduce the soil compaction with precision control movement. Same way our seeding and planting equipment, which I discussed previously. Fertilization and nutrient application, which will be also can be incorporated. Crop monitoring and data collections. Weed and pest control, which can detect and remove the weeds on a minimal herbicide usages. Multi-tractor coordination, where our fleets are going to be taken care with autonomous tractor for large-scale farming, synchronize the operations to optimize the time and usage of fuel. So, the benefits of autonomous tractor, mainly it is going to enhance the operational efficiency. As I am not going to speak about the working principle of the autonomous tractors, because each company will be having a different working principles, different technology behind the same. So I'm not going to touch with the working principle of our autonomous tractors. So I'm going to directly enter with our benefits, which is going to enhance the operational efficiency while minimizing the rely on our manual labors, which is going to boost the precision in planting, fertilization, and harvesting processes, which is also going to lower the expenses on our optimization of our water usage, fuel, and chemical consumptions, promote sustainable and environmental friendly agriculture system. Autonomous tractors are mainly revolutionizing in our contemporary agriculture system, which is going to be more smarter, more efficient, and exceptional productive farming practices. You might ask me where we have seen this kind of autonomous tractors, or which are the companies which are working is Case IH, FNT 1000 value, John Deere 8R 410, New Holland T8 NH drive are some of the autonomous tractors which are available in the market. So now I'll going to speak about the drones in agriculture. Mainly, drones are our unmanned aerial vehicle as an aircraft which is going to function autonomously without the presence of a human pilot. Usually in our aircraft, we will be having a human pilot inside the system, but in this system, the pilot or the drone pilot will be with a on the ground, and the drones will be flying on the aerial precision ways. So what are the key technologies in drones? GPS and GNSS system. GNSS basically stands with our global navigation satellite system, which works and supports our GPS system, multispectral and hyperspectral imaging, artificial intelligence and machine learning, LiDAR systems, computer vision and sensors, thermal vision and technology, VRT techniques, high precision spraying system, autonomous flight and route planning, propulsion system and motors, obstacle avoidance and collision prevention, payload and gimbal system, IoT and cloud connectivity. The benefits of using our drones in agriculture is mainly precision farming minimizes the resource wastage. Accelerated field assessment is going to enhance our decision making on a real-time basis. A cost-effective substitute to our manual labors. Environmental sustainability by decreasing the excessive use of chemicals. Where are the applications of drones are used? Already everyone knows that we are going to use in our crop monitoring, mapping, spraying, irrigation and water management, even in our seeding and planting applications. Next would be our sensors and IoT in agriculture. So, as we all know, sensor is nothing but a device which is designed to generate an output signal to identify a physical phenomenon. The best examples would be light, heat, moisture, and our pressure. I wanted to add one more terminology. One I wanted to teach about the sensor is a transducer. Transducer is also a device which converts mainly one form of energy to other form of energy. The best examples are our thermocouples and pressure transducer. You might ask me, what is the use of transducer in our agriculture fields? I just wanted to tell you one quotation which is going to make your doubt clear is, all transducers are not sensors, but many sensors are transducers. We have a terminology that sensors are going to monitor with a distance, but the case is not going to work on the same when we are going to use it on a different condition. So that's the reason I just wanted to add the specified terminology of transducers. IoT, Internet of Things, is a network of connected devices which is going to collect and exchange the data with other devices and system. Once again, I repeat, IoT is not an alternative, but it is a addition to our system where it is going to connect all our devices and exchange the data with other devices and system, which based on that, we can work more precisely for our farming and monitoring and other management in our field. What are the key technologies mainly in our sensor and IoT? Mainly with respect to our sensors, the key technologies are our soil moisture sensors, optical sensors, environmental sensors like our temperature and humidity. The benefits of our, like we can use it in precision farming, water conservation, crop monitoring, livestock management, automated machineries, weather forecasting, supply chain optimization. The applications, we can use the sensors in our soil sensors, optical sensors, light sensors, ultrasonic sensors. Meanwhile, our IoT can be used in autonomous irrigation system. Both IoT and sensors can be used in autonomous irrigation system. When there is a lower level of water, we can switch on the motors. So this is one where the IoTs, and meanwhile, a person sitting in somewhere in America or UK or in any other nation can easily monitor using our IoT technology from anywhere in the world. Even our greenhouse automation could also be added to our sensor-based IoT monitoring systems. AI in agriculture. Probably this topic will be covered more depth in the upcoming classes. I just wanted to give you the basic idea about AI. AI in agriculture mainly involves in computational based learning technique where we are going to enhance the farming methods and increase the crop production, where our AI technology are capable of processing large amount or a vast amount of data, which is going to enable more for making our decision. When we have n number of data on the same crop or with respect to the same land, based on that data, it would be more easy for us to make a informed decision regarding the what can be done and what can't be done. Optimal planting, irrigation, and when to give the fertilizers strategies can also be planned. What are the key technologies of AI in agriculture? Mainly, we can use this in precision agriculture, predictive analytics as a part of our data analytics, automated machinery, computer vision, IoT and smart sensors, machine learning and data analytics, NLP, what we call it as a natural language programming, genomics and AI-driven breeding, decision support system, water management, pest and weed control, supply chain management, farm advisory service. The major benefits of AI in agriculture can be used as we had a discussion like precision agriculture, enhanced crop production, automation and robotics, sustainable methods, where the data makes us to inform the proper decision making, and livestock management. Machine learning in agriculture mainly focuses, it is, as we all know, it is a branch of artificial intelligence and a core branch of computer science, which enables the computer to learn from the data and enhance their performance over time to time basis So when I give a term called as, which is going to make the computer to understand and enhance the performance over time, we need to employ the algorithm on a regular upgradations. If the algorithms are not being updated, your computer can't learn and implement the latest technologies on the field, like examining the data, identifying the patterns. Based on that, the predictions can be predicted. What are the key technologies in ML in agriculture, like autonomous vehicle, natural language processing, or manufacturing areas, retail and e-commerce, energy, agriculture, environmental monitoring, robotics? The major benefits of ML in agriculture is, as we all know, precision farming, increased crop yield, diseases and pest detection, climatic adaptation, automation and robotics, livestock management, water management, supply chain management, sustainable practices, crop quality improvements, market insights, and labor efficiencies. Big data analytics in agriculture. So mainly big data analytics involves in our examining the extensive data set. The photo itself clearly shows you we have n number of data stored in our cloud, and it is a bidirectional way. It is going to take care of any information in the cloud, and it is going to be used by our data analytics tools to enhance the pattern and insight of an organization. To give a better decision making capabilities, we can use this big data analytics, where these technologies of big data analytics encompasses the tools like data storage, processing, and visualization of data for a better insight understanding and go with the decision making. The application of big data analytics in agriculture mainly works with our data-driven decision making, customer insight and personalization, operational efficiency and optimization, risk management and fraud detection, supply chain optimization, market research and competitor analysis, predictive analytics for future trends, enhanced customer service, innovation and product development, compliance and security. Now, let us get into the case studies of automated farm. So, here I just wanted to take an example of America, where the success story basically starts with our automated farming, where many of the companies in US, such as our John Deere is one of the company, where they had developed the see and spray technology, which is going to use our AI to target weeds and spray them. This is one technology. Parallelly, we can promote the same thing for checking the moisture level in our horticulture crops like mango and other tree-based agriculture crops or tree-based fruit crops. In case if there is a less amount of moisture content in a row, assume we have around 100 trees. The first tree is having less amount of moisture and it wants to give some amount of water. The robot is going to come at that first tree and it is going to spray a required amount of water. Same way we can upgrade it to the nutrient requirement, etc. too. Second tree, it has enough amount of moisture, so it is going to eliminate the spraying of water in the second level. And the third tree requires some amount of water. The same scenario is going to work. For this flow, we need to use certain case conditions under our algorithmic implementation. During our programming stages, we are going to differentiate the things and we are going to write the programs. So the see and spray system, which we were speaking, uses a drop-by-drop significantly along the side of the crop. The better example includes our autonomous tractors, robotic fruit pickers from abundant robots, where our precision agriculture tools, which is going to measure the field on a real time for smarter water and fertilizer application, which increases the profit of farmers while decreasing the expenses because of the technique of precision. All of this improvements may lead to our global agriculture to a better standards. So the automated farming success stories in the USA mainly works with our John Deere see and spray system, where the AI system, as I told you, identifies and sprays the system. As a result, our herbicide usage drops dramatically, and where it is used, how smartly it is used, demonstrating for the farmer a clear region of interest. Autonomous tractors like our John Deere and other companies are also building fully autonomous tractors which can work independently without any human interventions. The tractor operates by its own, allowing the tractor to continuously work, which increases the productivity for the farmer. Robotic fruit picking, as I had shown in the previous picture, where the robot was picking the apples. Parallelly, it can also, in the initial stages, I was showing with the strawberries too, which can autonomously and delicately harvest the apples, thereby cutting down the labor cost and improve the quality of the produce. Precision agriculture mainly, as we were discussing, it is going to use our sensor and analytics to examine the specific field condition and then accordingly provide the water fertilizer tailored to the formulated crop to maximize the yield and reduce resources waste. Robots for managing the weeds in our automated farming in our USA used to work with companies like our Carbon Robotics are creating a system for laser weeding technique. As when I was explaining you with the weeding robots, this is the company where they have developed with our laser weeding techniques, where this system is going to single cut the weeds while preserving the crop and making it more precise and eco-friendly option for our weed management. This is one case study about the automated farming in USA with respect to our automated farming sector alone. The next case study is with respect to our Japan. So Japan, we have a company called as Meadow, a Japanese company which has developed a fully automated harvesting robots for tomatoes, which helps to lighten the workload mainly for human workers. With the progress of our AI and robots, Japanese agriculture is ready for automation and modern farming techniques where this robots can harvest close to 12 kg per hour with a working time of 14-hour operation on a single charge. You might ask me on what basis it is going to harvest. We have designed an AI algorithm to identify whether the fruit is ripened, what is the color, what is the size, and we do have certain other parameters. Based on this parameters, the robot is going to harvest the crop. Next, the case study with respect to the automated farming in India. One of the most cited example of automated farming in India is the application of drones with multispectral image technology to monitor the health and crop as well as the area-based pest activities and also aid in the precise and heavy applications of fertilizers and pesticides across vast farmlands. There is a drone company called as Daru Brahma for a variety of crops including rice, cotton, mangoes in the region of Odisha, Andhra Pradesh, and Gujarat. They try to optimize the resource allocation by decreasing the amount of chemicals utilized. This is especially helpful for resolving the shortage of skilled labor and increasing the productivity in our Indian agriculture. You might ask me what are the key points about the case study of our. One thing is the technology, what we have been incorporated as drones with the advanced analytics of data algorithms and multispectral cameras. The benefits of this is like crop monitoring, precision farming, pest targeted optimization, fertilizer application optimization, enhanced yield, and reduced chemicals. Mainly, they have worked with the targeted crops like paddy, cotton, chilies, mango, cashew nut, peanut, sugarcane, and tea, etc. Outcomes: improved productivity on farms, conservation of resources, possibility of sustainable agriculture, What are the other instances of automated farming in India? Mainly, we have used our GPS in tractors for soil-based targeting, for sowing and fertilizer application, which helps the decrease in our wastages. Irrigation system with utilizing our IoT technologies where our soil moisture sensor are able to track the moisture content in the soil and automate the irrigation process, where this is going to ensure maximum efficiency. Disease identification using AI system. Early detection of plant diseases is done through the analysis of drone pictures with the help of sophisticated machine learning algorithm. When we are going to write the algorithm, we need to have enough amount of photos or data. Based on that itself, we can try to program. Probably you might start asking me what is accuracy level, etc. Depends. If you have enough amount of data, it can even reach to 80 to 85%, sometimes 70 to 75% also, when it is in our pest and disease management. Major challenges of our automated farming. The major challenges of our automated farming range of advantages, but also introduces several challenges which must be overcome in the upcoming areas. Like I can say, significant initial cost where the investment is required for purchasing the implement is more. We need to maintain the automated equipment, sensors, softwares, and other technologies can be considerable, creating a major financial hurdle, particularly for the smaller farmers. Technical complexity, where the operation and upkeep of advanced automated systems demand a level of technical knowledge and training that may not be easily accessible to all farmers. Infrastructure needs. Automated farming typically depends on strong infrastructures such as dependable internet access, power supply, and data storage capabilities, which may be insufficient in certain rural conditions. Data management and security, which is very important thing where our automated system produces large volume of data, which must be efficiently managed, analyzed, and protected against the potential cyber threats and data breaches. Environmental issues when we get an heavy machines can result in soil compaction, diminishes the biodiversity and greater dependencies on chemical input, which could negatively impact in the environment. If we are not going to specify the condition or if we are not going to give a crop specific data. Employment impact, mainly the rise of automation may result in job losses within the agriculture sector, especially the manual labor roles, which could affect the rural communities. Ethical issues where the data privacy, ownership, and the risk of the increased inequality, unequal access to the technology, which may need to be addressed. Flexibility and scalability of automation system, which is more flexible enough to adapt in various farming conditions, terrains, crop types, as well as scalability to accommodate different farm size and operational requirements. Maintenance and repair challenges encountered in the automated system can be difficult to the people, potentially causing downtime and interruption in farming activities. Social and cultural effects like the transition of automated farming may transform the traditional agriculture practices, and socio dynamic within the rural communities require careful consideration and management. Okay, these are some of the challenges, but how can we overcome these challenges? I just wanted to see. High initial investment. Mainly, if the government is going to support with some incentive, like financial assistance, grants, and tax incentive to motivate the farmers to incorporate this automated technology, leasing and cooperative models, like certain FPOs are going to get the equipment for a certain durations, where they can lease with their farmers and even gain certain amounts. Like innovative approaches like leasing the equipment, shared ownership can also help, where it is going to lower the initial cost burden to the individual farmer. Gradual implementation, mainly farmers can adopt automation incrementally, focusing on specific tasks or areas first, which allows them to distribute the investment over a longer period. Technological complexity, where majority of the feedback we are going to get. So how we can overcome the technological complexity in this sense? Training and development of the program. It is vital to offer the farmers extensively. Training should be conducted, the education materials should be shared on how to operate and maintain automated system design. Manuals should be prepared and shared to the ground level farmers in their local languages may also be helpful for them. User-centric design. Technology developers or our core engineers should prioritize creating a user-friendly and intuitive interfaces for our automated system. Accessible technical support, where one can provide easy accessibility for technical support and maintenance service, where they can assist the farmers in resolving minimum changes without reaching to the nearest company. So next, I just wanted to get into the infrastructure requirements, mainly enhancing the rural infrastructure requirement, like our both government and private entities must invest in improving the internet access, power supply, and our transportation system in the rural regions. Exploring off-grid solution, where we are going to investigate alternative energy sources, and off-grid solution can also help to mitigate the infrastructure challenges in remote location. Data management and security, which is going to standardize the data and interoperability. Developing the common data standards and protocol can enhance the data sharing and analysis across the various systems. Implementing cybersecurity protocols, how we can save our data. Certain trainings can be given with respect to the same. Clarifying the data ownership and privacy, where there are clear regulations and guidelines regarding the data ownership, privacy, and the address ethical issues. When it comes to our environmental concerns, mainly precision agriculture techniques, sustainable farming practices, job displacement, where we can try to retrain and upskill the programs by implementing retraining and upskilling the initiative of agriculture workers, which can facilitate their transition into the new roles within the automated farming or related sector. Creating new opportunities to the people by identifying the new roles in the field like data analysis, technology maintenance, farm management can help job losses, ethical consideration, fostering open and inclusion discussion with the farmers, workers, communities, developing ethical guidance, adaptability and scalability, modular and flexible systems, customization options. Providing customization option is a very important thing which works on the needs and requirement of different farm size and operational skills. Maintenance and repairs, which is a very important aspect, where we are going to prevent the maintenance program, like establishing preventive maintenance initiative and training farmers in basic maintenance tasks can help the reduce downtime. Remote diagnostic and support, what we call it as a troubleshooting options, where they can use the diagnostic tool and support system can facilitate the rapid identification and resolution for their technical issues, are some of the solutions for this thing. Future trends in automated farming mainly works with our advanced robotics and AI, sensing and imaging technologies, which we discussed about hyperspectral imaging technology and LiDAR technology, biosensor innovations, automation and control systems, data analytics and its connectivity, biotechnology and nanotechnology, mainly in gene editing methods such as our CRISPR, which are employed to create crops with enhanced characteristics, including resistance to disease, tolerance to drought, and increased yield. Nanotechnology part, where the application of nanomaterials is advancing with the development of more effective fertilizers, pesticides, and sensors, which also enhances the soil health and water management practices. So, economic impact, I just wanted to give a few points to you. Is it audible? Hello? Hello? Sir, is it audible? Any of the participants can kindly confirm me? Hello? Any of the participants? Is it audible?
Yes, sir.
Yeah, thank you, madam. So, when we get into the future trends in automated farming, mainly we are going to focus on our advanced technologies like implementation of advanced robotics and AI, where we are going to enhance the dexterity in robotics, which is nothing but recent advancement in our computer vision, machine learning, grasping the technology, which is having a significantly improved robots' ability to perform the tasks such as our fruit harvesting, weeding, and other activities and manage the same. Collaborative swarm robots, which can be developed for our small scale farmers, cooperative robots, which is already on a rise, enabling them to work in unison to accomplish tasks more effectively and adapt the adapt to our field conditions mainly. So sensing and imaging technology like our hyperspectral imaging technology, it is a kind of an innovative approach which is going to capture a broad spectrum of electromagnetic wave compared to the conventional cameras. Yielding is going to be comprehensively insight into the plant vitality, soil health, and water stress. Parallelly, if we are going to use our LiDAR technology, which is nothing but our light detection and ranging, which is going to employ with our laser technology to generate the three-dimensional representation of agricultural field, facilitating to more accurate navigation for robotic system and tailored application of our agricultural robots. Biosensor innovations, which is going to miniature the devices and are capable of handling the real-time monitoring of our plant health, soil condition, and animal well-being, offering in a early detection of our potential issues. Meanwhile, our automation and control system like our self-driving tractors and equipment, small irrigation solution, VRT technique, data analytics and connectivity mainly handles with our farm management system, IoT and blockchain technology. So blockchain I just want to touch because the technology is mainly used in the tracing of the products throughout the supply chain and enhancing the food safety and fostering our consumer confidences. Next is our environmental impact of automated farming. So when we are going to speak about the environmental impact, I just don't want to show only the positive impact of the environmental impact. I will be discussing both the positive and negative side of the environmental impact. So minimize resource usage of our precision agriculture is a add-on to us, targeted application, enhanced soil quality by no-tilling farming, cover cropping, water efficiency like our precision agriculture, drought resistance, lower greenhouse gas emission, energy optimization, carbon sequestration, biodiversity enhancement like habitat conservation, crop variety, etc. When it comes to the negative impact, soil compaction, I used to repeat during the current session. When there are heavy equipments, the use of large heavy automated equipments can also lead to the soil compaction, which diminishes water infiltration, obstruct the root development, and may also result in the soil erosion. But we do have a many positive side too. Energy consumption, where we have electricity usage is not so easily accessible in the certain rural conditions. Dependencies on external inputs for our chemical usage. Monoculture practices, which is going to decrease the diversity. Environmental pollution by e-waste, mainly when we are growing the reliance on our or rely on our electronic devices and sensors in automated agriculture, can also result in the production of electronic waste, which must be managed appropriately to prevent our environmental pollution too. Economic impact of automated farming. So the economic impact of the automated farming mainly enhances the productivity and efficiency, like improved yield, where our automated system can enhance growing conditions, result in higher crop yield and livestock output, lowering the labor expenses. Automation usually decreases the relay on our manual labor, thereby reducing the cost for farmers. Efficient resource management, where our precision agriculture is going to reduce the wastage of resources like our water, fertilizer, pesticide, leading to the cost saving and improvised efficiency. Continuous operation, whereas these robots can work round the clock and it can be continuous if you have an alternative set of batteries. Boosted profitability. Mainly, expenses are going to be reduced. Superior quality products can be into the market, enhanced market competencies, where our farms which have been implemented with automation may gain a competitive edge in the global market throughout the improved efficiency and productivity too. Social impact of automated farming. Mainly, I'm going to speak what are the social impacts, like enhanced working condition, like minimized physical strain, where automation can assume physically intensive and repetitive tasks can be done without lowering the risk of injuries and enhancing the working environment for agriculture laborers. Self-work environment, where the robots are capable of performing hazardous duties such as pesticide application, which decreases workers' exposure to our harmful substances. Skill advancement, where technology proficiency like our agriculture increasingly incorporate the technology, workers will have the chance to acquire new skills in the field such as our data analytics, robotics, software management, and based on the market trends. Creation of skilled position, where the rise of automation may result in the emergence of new higher skilled roles in agriculture, providing improved salaries and career prospects. Rural renewal, mainly appealing to younger generation, is very important because recently in one of the session I heard that it is very much tough to train the people. So we need to mainly focus on the rural generation, rural aspect to the younger generation, where they are more attractive to the automated farming system, where our younger individuals are more technology oriented. We need to guide them with the careers, whatever is available, potentiality for reversing the trend of declining the rural population, community growth, where we are going to revitalize the rural economies, can bolster the local enterprises, educational institutions, and infrastructure, fostering overall community development, enhanced food security, where it is going to increase the production level and consistent food supply. Ethical consideration and automated farming, mainly, which is a huge problem in the entire world. I can say this. Data privacy, safeguarding the confidential information of farmers, gathering through automated system, which is going to encompasses the specific data of the land, crop production, agricultural methods, and even unauthorized access to that specified data. Equity and access, guaranteeing that smallholder farmers and underrepresented communities can access the automated farming technology, preventing them from being disadvantaged due to financial constraints, can also be an ethical consideration. Policy and regulation in automated farming. So mainly data privacy and security, where the regulation may dictate the methods by which data can be gathered from automated system, like our soil condition, crop health, and weather information is stored, accessed, and utilized, thereby safeguarding our farmers' privacy and ensuring the security of their data. Equipment safety standards, where we are going to set a specified policy from the end of the automated machinery equipment, encompassing the design specification, operational guidance, and emergency response measure to avert accidents and injuries mainly. Environmental impact assessment care should also be taken care. Like regulation may require environmental impact assessment, like for automated agriculture practice, to evaluate their potential effect to our soil health, water consumption, and biodiversity. Ethical consideration, like policies may tackle ethical issues in our animal welfare and automated livestock system, including monitoring and intervention strategies. Labor impact mainly. Government may introduce certain policy to assist the workforce transition, as automation may lead to the displacement of certain agriculture jobs, mainly potentially offering retraining or income support initiative. Potential policy approaches like incentive for adoption of the technologies from the government might provide some financial incentives like subsidies or tax deductions to motivate the farmers to embrace our automated technology, particularly beneficial for our small scale farmers and producers. R&D funding mainly, where our investment to the research to enhance the automated farming technology and address associated challenges, including sustainability and socio implications, which is a very crucial task. Collaboration with industry, engaging with agriculture technology firms to formulate the policies which is going to promote innovations while managing associated risk is also essential. So the major challenges in automated farming regulations, like technology complexity, regional adaptations, equity and accessibility, and data governance. So what is the global perspective on our automated farming? Mainly like our tackling our labor shortages, precision agriculture, data-driven decision making, and emphasis on our sustainability. Roles of our startup companies in automated farming. So one, we have certain software startup automated companies. The technology advancement in agriculture startups are at the forefront for developing the advanced technology such as AI, IoT, robotics, drones, and ML to enhance the agricultural practices. Notable innovations including our self-driving tractors, automated harvesters, and AI-driven system for monitoring the crop health, enhanced precision farming's commitment to sustainability for the startups, improved cost efficiency by automatic labor-intensive process. Startups assist farmers in lowering their operational expenses. Insight of our data analytics, startups offer certain platforms to make use on a free basis, get trained, and then give it to the farmers. CEA technology, where our controlled environmental agriculture innovations, where this innovation can also allow for us to continuous crop production in urban setting, thereby lowering the transportation cost and reducing the carbon emissions, streamlining our supply chain process or using our automated farming techniques. Future of automated farming and robotics. The major future is set to experience the emergence of sophisticated robotics and collaborative automation system works mainly on our advanced automation and robotics, AI and ML, IoT and smart sensors, drone and aerial technology, vertical and urban farming, sustainability and resource efficiency, and human robot collaboration are some of the future areas where our automated farming and robotics are going to do. The overall summary of today's session is mainly with respect to our various technology which has been used in our automated farming, benefits of automated farming, different applications used in automated farming, various challenges were addressed, roles of startups, future trends of automated farming, and robotics were also spoken. So now I just wanted to play a video how it is going to work in our regular field. Before that, please let me know whether you are going to get the sound of the video so that it audible? Is it audible?
Yes, sir. You are audible.
No, the video whichever I played, was it audible?
No, sir.
Okay, then not a problem. I'll just try to share the video so that you can just have a basic understanding of autonomous system, how it is going to work. So that's about it for the today's session. If any Q&As are there, you can just start asking me for the current Q&A sessions. I am open for the discussion. If anyone has any queries, please, you can try to ask me. Shreyan, sir, actually you were asking me about aquaphonics. So aquaphonics in automated system mainly works like on the top layer, we will be having the fishes. With the fish waste, we are going to grow the plants. So if you are asking me with the detailed aquaponics, I'm not an expert with respect to aquaponics, but how the automation works with respect to that context, I can help you out, sir. So Praveen, sir, you were asking me about Kisan drone pilot. Sir, I want to know about Kisan drone pilot and its scope in India. Sir, basically like drone pilot, whether you are asking me about the drone pilot license or what, can you just tell me? So drone pilot license, it is like you need to get training with a DGCA approved agency. Once you get a training, you will be having both practical and theory classes. Once you clear their exams, you are going to get the license for the same, sir. Logeshwaran, sir. Actually, robotics for pest and disease management, mainly pest and disease management mainly works like we need to have enough amount of data, sir. Like assume it has been attacked by any specified pest. With that pest data by our experts, like assume we have a data from our entomologist or pathologist, that set of data for a specified crop based on the photos we are going to frame a algorithm. With that algorithm, the AI is going to diagnose with the set of photos and it is going to determine the whether it is a pest or not. So everything works mainly with our expert teams. It is not like the robot. We need to program the robot basically, sir.
Hello. Sir, what are the robotic costs? You have a question.
Robotic
Robotic causes
process
errors.
errors.
Yeah, sir.
Sir, robotic errors mainly. So I would say the error might happen on a very rare cases due to some software issues or sometimes even with our identification errors. The identification errors, because it is going to happen, we don't have enough amount of data. So at that case, we might find some errors. Again, it is plus or minus of 5%. Sir. Even we make that error in certain conditions like whether it is a nutrient deficiency or disease when we have allowing in our plant leaf. So such kind of plus or minus are there, sir.
Sir, you have a question that how we can manage it, sir? That robotic causes errors.
So robotic errors mainly can be depending on what type of robots and what is the situation. Based on that, we can try to manage, sir. like whether it is working on or is there any alarm off issue, on issue, it is not able to perform the given task. Well, based on those errors, we can try to troubleshoot the things and give it to the people, sir.
Sir, another question here. What about pest detection using image processing or sensors we can use, sir?
Absolutely, your sensors are going to fetch the data, sir. Whatever the data are fetched by our sensors and cameras. Mainly image processing is going to work with our data with or the photos that will be segmented and processed. So it is a collaborative technology, we can say, sir.
Participants, any questions here?
Any questions, please?
Participants, any questions?
Everyone,
Greetings.
mic now turn on. You can-
Hello.
Hello.
Yes, sir.
Good evening. Good evening,
Good
sir.
evening.
Thank you for the wonderful session.
It's my pleasure,
Uh,
sir.
yeah. So actually, I'm little bit confusion about drone sprayers. Okay.
Yes,
As
sir.
you said in the PPT,
Yeah.
it will detect the pest or fungal attack, whatever it is, while spraying
Sir,
the fertilizers.
yes, sir.